It's just the this one was higher. That's what I wanted to do. Do you understand?
Yeah.
Okay, so where did it stop?
I think the mic is working.
Is it working?
So, can you hear me?
Okay, it's working.
Yeah, mic.
Hey guys.
Yes, I can hear you.
It's not online.
So we remove some cracks paper then to sustain. We jump to 3%. So because of that, but this one was delivered to us. Hello? Yeah. Yeah, morning. If you read something to me about shit, so I don't know, I don't know if from that minute. The body is respect. I don't know the person that I received some of these items from Mr. Payne. The energy is far better. He can send from his own experience, from what he said, that is the time I don't know to make out what he wants to achieve. And I should check it also. So being that day was weekend, so I didn't know that. I might have to go to that. So I don't know what to do with it. So that it will be at the end, you can't get the necessary facility that I received. I think someone from the material movement here brought that. Essentially, if you're not safe, I'll check now. Then the vendor this thing will work. So I don't know how we'll go about it at this stage.
Oh yeah, talk. I'm the one they can hear.
Yeah.
Can hear me. So that's the one.
Searching somewhere.
Are you seeing video goes to camera?
It's like a movie from where some show name. This one is for name and stuff.
Maybe that's what we use
the
in the
other time.
conference.
It worked the other time too. Like when we did
When did the first time the mic was with?
and now. when you were talking. Since then,
Okay.
Like you have to use another.
hello.
Hello. Hello.
There's a setting.
This one is no more talking. It's taking it from here. It's meant to be from there.
CITs, I can hear you loud and clear.
Yeah, at the moment it's disconnected.
No. Good.
Hello, can you hear me? Ask me if you can hear me.
I can hear you. CITS audio.
Okay, can you hear me now? You can hear me now.
Yes, I can hear you.
Can you hear me now?
Yes.
That is shaking.
No.
It's looking loose. It's loose.
Shoot.
Come to your this thing and click on this speaker. Maybe you should go to Zoom and click on this.
Hello. emerging technology. This is day 2, and it's the final day. It promises to be an exciting. Foremost, I would like to thank everyone that was present yesterday. Our chief host, in person of the Vice Chancellor, our host, the dean, our own head of department, our amiable Dr. Ezro Aketono, the visionary of this conference, our sponsors, our sponsors, MTN, Smile, and our special guest of honor, the MD CEO of Unicello's group of companies. We thank you very much for this opening ceremony yesterday. And more importantly also, we thank all our keynote speakers at home and abroad for giving us such a robust topic to discuss on. Many, many thanks to you. And our presenters as well. So thank you for giving us stimulating ideas, which we believe will take back to our research lab, research institute, for further development. And as we do, we'll have a transformed environment transformed by the grace of God. Today, I want to intimate us a slight alteration in the order of activity. After this opening, we shall have the plenary session. Will not be taking place because the presenter just lost a dear one, so he will not be making the occasion. So immediately after the first keynote address, we go for the tea break, and then after the tea break, we come for paper and poster presentation. To open this ceremony today, we'll just take the school anthem and then thereafter the national anthem. The school anthem and thereafter the national anthem. Thank you. Can we rise, please? You may be seated. Straight away, we go into the plenary session this morning, and to give us the keynote address is once again Engineer Oluwole Adeoti. And just before he comes up, I read a bit of a citation here. Engineer Oluwole Adeoti, Operations Manager, Main One Data Center, Lagos. Oluwole Adeoti has about 15 years public experience in information technology infrastructure and project management in both servicing and the financial sector. He has been involved in a range of activities ranging from core IT infrastructure, alternative power, that is solar energy, and data center build, process improvement and management. He is a certified data center operations manager, certified data center design professional, CNET, ISO 2000 service management certified, certified enterprise architecture, SON certified system and network professional, Cisco certified design professional, certified project manager, and certified business continuity professional. Currently, as the data center operations manager, is responsible for coordinating team of engineers, technicians, and managed services in the development, consolidation, management, and support of Main One data center facilities. He provides leadership for the highly skilled technical and supporting staff in a 24/7 operation, lead innovation, and ensure continuous improvement of professional processes and procedures. He also leads the performance management and capacity planning for all aspects of the data center infrastructure and ensures 100% availability of Main One data center facilities. Please join me in welcoming Engineer Oluwole Adeoti. A round of applause for him. Engineer Adeoti, over to you, sir.
Thank you so much. I really appreciate the privilege and opportunity to be part of this noble event. But before I go into my presentation, preliminary presentation this morning, I would like to acknowledge the chief host for this occasion, Professor O. Ogunbiyi, and the Vice Chancellor of University of Lagos. Also, I would like to appreciate the host, Professor O.M. Hello, am I audible? Hello?
We can hear you.
Oh, okay, thank you. Now, like I said earlier, I'm acknowledging the chief host, the host, Professor O.M. Sadiq, the Dean of Engineering, and Dr. S.O. Aditson, the head of the Department of Electrical Engineering. And also, I would like to acknowledge the conference advisor, Professor I.A. Moete, and the technical program committee. And also, I won't mind mentioning the name of a good friend of mine. We've been friends for decades in the industry, and that's Dr. F.L. Oboe. It is through him I got the link for this presentation this morning. I said, thank you for the privilege. Also, it's worth mentioning the students If not for the electrical engineering students, there would have been a section like this. So I really want to acknowledge them too at this time. A lot have been said about me, but before I start my presentation, I want to say a little about myself again. Like the speaker said earlier,
Sorry, it's not audible, please. Can someone help?
hello?
We can hear you now.
Okay, so I was trying to say, I presently work as data center operation manager in May 1 data center. And like I said earlier, our vision is to be West Africa premier data center and interconnect solution of choice. We have our head office in Nigeria. And we build an ecosystem across West African sub-region. We have a data center in Ghana. We have one in Cote d'Ivoire, and we're planning to, expand across all the West African sub-region. Our aim is to build the right ecosystem within West Africa sub-region. As you can see on the title page, this morning we'll be taking us through a walk on what I title Data Center, the key driver of growth, and how we can optimize our data center through Internet of Things and artificial intelligence. Some of these we're doing now, and there's still a lot of room for improvement. A lot of technology are coming up in this space because, whether I would like it or not, data center has come to stay in this world of ours, because as data continue to grow, then there's a need for us to warehouse the data. So the form of data center will continue to change, which we're going to see in the course of the presentation. But one thing that is sure is that data center business has come to stay in our time. So let me just go straight to the what I have here. I don't know, is my screen visible?
Yes, very visible.
Okay, so just go straight to my introduction. I want this to be more engaging. I'll do less of reading. I won't mind if so I can have enough time to discuss and have enough time to respond to people's questions around data center. Like I said, I'm going to discuss about data center, the key drivers of growth, and how we can use artificial intelligence to improve our operation. Have it here that the growing demand for big data and the role they play in the digital ecosystem. We all know this very well. It is important we have a reliable facility, a data center where computing device carrying this data workload can be secure, readily housed, available, optimized, and easily accessed. What is a data center? We all have a different definition for data center. It could be called a data hall, you could call it a data farm, you could call it a data warehouse, we call it a hosting facility, you could call it a co-location room, you could call it a computer room, or a server room that most of us are familiar with. Though from time to time, as technology advances, what we call the data center is changing, and it will continue to change. It will continue to change as technology evolves. The data center to what we call the data center will evolve. And like we all know, before now, a lot of people try to have their own small server room data center. But today, what we have today is either we have a lot of that is shifting now. We are moving towards what we call co-location service, and that too, with time, we definitely shift to the cloud. Now, according to United Nations prediction, we have about 7.8 billion people in 2020, and this will reach 8.5 billion in 2030 and 9.7 billion in 2050. And over 40% of this world population are going to be internet users, And that means the demand for data, the demand for more use, there's going to be more demand for data center, because like I said earlier, as we have more internet users, we create more data. As we create more data, this data needs to be warehoused, irrespective of how we warehouse our data today. The most important, the data needs to be warehoused. So the success of a data center is measured based on its ability to avoid failure, how quickly can a data center recover from failures that may occur, and how can they operate at minimal level of power utilization efficiency. Because again, this translates to cost. Where your efficiency is very, very low, you spend more money on power. Then when you spend money on power, your operational costs will be very, very high. And when you have high operational costs, then you are not in business. So you just have to optimize how your power is being utilized, because power is one of the critical infrastructure that will require to ensure your data center continue to run. According to Uptime or Tier Institute, we have 4. This is just a broad introduction. We have 4 tiers of data center. We have tier 1, which is the least reliable, and we have tier 4, which is the most reliable. In the course of my presentation, I'll be going a bit granular on this for those that might be, those that will be interested in this. And the data center, the data center trend that will be discussed just provide a blueprint on how data center is being run today and how data center will evolve in the future. Then at the end of my presentation, I'll be talking about how we can leverage, how we've been leveraging now, and how we can further leverage on Internet of Things, artificial intelligence, technology, machine learning to optimize our performance in the data center. Now, why are we talking about this? I think this again will help those of us in the research world to know what is obtainable in the industry and how we can better position our resources to serve the industry better. And again, give an eye opener to our students so that they could see what they expect. And those of them that are very inquisitive or those that are innovative, they can see what they can work on and how that can make meaningful impact in our industry today. So I will just go briefly to some of our critical infrastructure in the data center. I will not bother by reading all through this. We have the slides, so we can do that on our own when we get the slide because of our time. So, but let me just speak about power. Power is key to data center because the data center I run today, you have to be up 24/7. And because if you are not up 24/7, the impact and the implication is huge on both on you, the provider, and even your customer. At least the experience that we are familiar with, you can imagine you going to your ATM today and you can withdraw money. You know how that impact can be on you, and that impact is cascading. You know, somebody might be sick in the hospital today and you need to withdraw money to meet their need, and there's no power at the data center. The power that you have in the data center, we are fed the operation of this institution, because today, like I said earlier, data center is gravitating from what it used to be, where you have it in your own house, to a colo environment like ours that I manage at the moment. So power is a very, very critical infrastructure for me to run my data center effectively. And this power comes in two forms. It could either be AC power or a DC power. The next critical infrastructure that I would like to just discuss briefly is cooling. Cooling is key too, because we know the equipment that your server equipment generates heat, and that heat from that is generated from the equipment needs to be cooled so that the equipment will not malfunction. So the cooling today is either you have the chilled water system, or you have what we call the direct expansion cooling technology. But like the most of, I have the mix. I have the mix of both technology, both direct expansion and the chill water system. I have both, but like I said, this is not the class for cooling. I just need to mention this, so I'll be moving fast on that. And the next critical infrastructure I would like to talk about is connectivity. Now, this is very, very key, even in modern day data center or the use of data house, because like I said earlier, we are gravitating from where you have your own data center in your house to where this service is being outsourced. Now, if you're going to outsource this service, then connectivity is very, very key, because you have to remotely access your data over the network. So without good network, it will be very, very difficult for you to have this. Even your phone, you know, you're like most of, let me just make an analogy. Like most of the Yahoo, most of us have a Yahoo account, we have a Gmail account. You need connectivity to connect to your Yahoo account. Those accounts is being stored in a data center, in the form of a data center. So when we're talking about data center, so connectivity is very, very key in you having a good data center. So the next technology I want to talk about, infrastructure I want to talk about, is security. Now, without security, this is both physical and it's going to be both physical and software security. Because without security, then if your data cannot be secured, then you have no data center. When you go to most colo location, most of the big data center, you see heavy security, physical security, you see armed men, then you see a lot of barricade that is being built just to protect intruder. That is, I'm talking about the physical security. Some of them will go as far as hire armed policemen that guide the environment 24/7, because if your data is not secure, then there's no how you want to go and keep it in that colo location. Then another security threat that what I mentioned is the cyber crimes. That is the software security. That one too is key. A lot is being done in this space too, to just ensure that the data that is being kept in the data center is secure and safe without any loophole. So, having said that, I'll be going to what I term the critical success factor of a data center. Now, when you want to design a data center, there are some things we look at. We look at reliability, and even either you building or you trying to outsource your data center services. These are some things you look at. You look at the reliability of the data center. You look at how available this data center can be. You look at how serviceable that is. Okay, yeah, I have issues. How can I continue to maintain? How can I continue to service my customer? Continue to service this company? And then you look about capacity. And how can I ensure I have the capacity at all times, even if I'm going in now, requesting for a particular rack capacity? How am I sure that in the future I can have more capacity as I grow my data center footprint? So you have to put all that into consideration when you want to outsource or you want to build a data center. Another thing is scalability and growth plan. Is very key. Manageability, criticality. Then the final one, which I would like to dwell on more, is policy, process, and procedure. You know, this is a major player here. You find a lot of data centers today, they are built, which I'm going to explain later, they're built to build a lot of redundancy. But one critical success factor is you having the right policy, process, and procedure in place that governs your operation, because the success of a data center depends strongly on this, because there's no room for mistake in the data center. There's no room for mistake. You must have enough policy that guides how you operate. There's process in place that ensure what you do and how you what you're doing, how it relates with other units that you all work together, and you have procedure that governs your daily operational activities. Before you do anything, these are the procedure you need to follow. I tell you, once you have the policy in place and you follow them religiously, the chances for failure is very, very minute, because before the failure crystallizes, you will have seen ahead of time, and you, to a large extent, might be able to mitigate against this failure. See, a lot of data centers have failed today because of this. And we're going to see how artificial intelligence, Internet of Things, and machine learning can help us improve on it, because this will require a lot of human intervention. And when you bring in artificial intelligence, Internet of Things, or machine learning into this will, it will reduce, reduce the involvement of humans in the doing of things. And when you reduce the involvement of humans, failures that could result to human intervention will greatly minimize. So policy, process, and procedure is a very key. It's soft, but very, very key success factor for a data center business. Now, let me talk about the trend. Now, by 2025, this is according to research done by Uptime Institute. Uptime Institute is one of the governing bodies that governs the operationalization and sustainability of data center. This research was carried out in 2020. They said by 2025, most data centers from the research, they said 25% of their power will come from solar energy. Going green. We want to keep the environment safe. For now, we're doing around 1 to 3%, but they are there, most especially the big player. Even coming to Nigeria today, one of the things they asked you stand a better chance if your data center can be green. The more green your data center is, the more better opportunity you stand having them co-locating with you in Nigeria today. So a lot of work is going on around this space. Many people are trying to go green. So there's a lot of opportunity in that space for those who will be interested. Every data center today, like mine, we're working on this too. A lot of engagement is ongoing. Even though if not for anything, we want to make our non-white space load, that is the domestic load. Now let's even power them with green power. Let's show that let's show that support for the green strategy. So it's what we are really doing. The other trend that I would like to speak about is cloud adoption. I'm having a discussion. I was having a discussion yesterday with my CEO. He said one thing. So, Wale, you get to know that in the next few years from today, we might not have most of this lot of customers that you have today. The data center that I operate is a multi-tenant data center. I have a lot of co-location customers. I have a lot of banks today co-locating with us. So I manage quite a number of customers. Like today, I have my data center is about 600 racks, and I'm currently we're building an additional 520 racks to make it 1,000. That is in Nigeria, to make it about 1,100 rack space data center. He said something that really struck me. He said, Wale, now some of the policy and processes that we build around today for this customer, in the next 4 or 5 years, those policy might not be applicable. So we need to be nimble, we need to be flexible, we need to be agile in how we need to be more flexible in how we change in our policy. Now, what about this? A customer was asking for, now I do 15 minutes response time. A customer was asking for a 5-minute response time. I was like, it's not possible, because for my GNOC, my general network operating center, to respond to a customer, the SLA I have with them is 15 minutes. Now, how will I serve this customer? It's one of the big players. How will I serve this customer within 5 minutes? He said, well, come. So these are the future of data center. And in the near future, all your clients today that you think you have now, that you're building your process and procedure around, they're going to migrate to the platform owned by this customer that you are unwilling to attend to now. And maybe in the next 5 years, you just have 6 or 7 customers to manage. And so are you now telling me if you have 6 or 7 customers to manage, you will not be able to do your response time of 5 minutes? The answer is no. With 5 customers, that response time we achieve. I can even do 1 minute. Now I'm doing 15 minutes because I'm looking at the number of customers I need to respond to and the time to respond to them. So he said, these are the future. So in no time, most of the banks that you have today, they will migrate into cloud platform. And when those customers are in cloud platform, so your customer in the future will be the cloud provider, because are going to be your customer. So the old rack space that you're having today now might just be old, might just be bought by just 5 or few of this cloud providers. So she said, Wally, your target now should be those cloud providers. At least plan ahead to accommodate them because they are the future of data, they're the future of data center. Now, the next trend I would like to talk about is adoption of hyper-converged platform. We all know computing, the storage, the resource-based software, everything is converging. You have a unified management interface, and even the cloud adoption too drives this, where you have, today, even without cloud, a lot of organizations, they are converging. We have upper converge, where you have a host of servers in a particular rack. I remember in my previous world, when I was still in the banking sector, we have virtually all our application on just one converged infrastructure from EMC. So, and again, this gives you a lot of flexibility. You can easily build your DR when you have all your platform, rather than you having 150 servers. 150 or more servers are being converged in just one host, one server with multiple hosts. So it makes management easy, it makes support so easy, and you can build enough redundancy across the platform. What you just need to do to build redundancy is just to replicate that particular converge in your DR site. And at any point in time, you can fail over whichever way and have your services more and more reliable. So it's a trend. This trend will continue. And again, because this will be a trend, management becomes more difficult. So artificial intelligence, because again, when you have multiple servers, easily you can do physical check. Human intervention is the key there. You can do a lot of things you can see, but when you are becoming more converged, now there are a lot of things I cannot see. So you need this technology. We need artificial intelligence. We need a lot of learning. We need a lot of Internet of Things to manage this technology for you to serve your customer effectively. Then again, another trend I would like to talk about is increasing connectivity requirement. As our data continue to increase, then the connectivity to will definitely will increase. You are converging. You can imagine you are having about 150 server in just one host. Then definitely the network requirement for that server will be definitely more than what you will need for just one server. Your normal 100 MB that you might need for a server might not really work here. You talk about in gigabyte. Like you can see, the adoption rate now, people are beginning to adopt the 200 and 400 gigabytes switch port from the existing. Before now, we have 10 gig, we have 40 gig and 100 gig gigabyte port. But now that they are moving from the 100, which seems to be the highest now, to 200 and 400 gigabyte switch. But we can see that too, at least from our phone, because that more time you need more network. At times when you have age, find out that you can do less. You'll be looking for where you have 4G network so that you can download more on your data. And there is talk now about the 5G. So the 5G is going to revolutionize the network world, coupled with the fact that the edge data center is coming up with the edge data center. We're bringing everything close to the customer. This is going to change the way a lot of things are being done. We hope to have a good experience, and we hope we have it soon in Nigeria. But the major challenge here is that technology is evolving. But are we really having the experience? I'm having discussion with some of my colleagues some days back. You go to the penetration level is still very, very low. You go to some area, you don't have 3G. No, we're talking about 5G. There are a lot of areas you can't even do 3G, you can't do 4G. Now we're talking about 5G. So it's not just enough for us to say we are advancing in technology, but how well are we doing penetrating this technology across the nook and cranny of the country? There are a lot of limitation, but that's not for our discussion this morning. So let me just go. The key driver of DC growth. What are things that is driving DC growth? One, growth in mobile internet and data consumption. That is one. Then two, Okay, still along that line, in 2022, mobile traffic is expected to reach about 77.5 exabytes per month, annual growth rate of 46. And this is driven largely by the mobile industry. You find that even when you go to local terrain, even though the network is not even good, they still manage to have all of them. Everybody today has phone and can do either one or two things with their phone. The other thing again, new technology and innovation are driving the demands. Are driving the decision making, and again, the need to store data offsite. And most of us today, we have our data. People, at least they're free data storage from Google. So this data need to be stored somewhere. Now, when you increase, you pay more money. So you can imagine storing all this. So data continue to grow. A lot of in the social media, people need to store pictures. Domestic use alone is quite huge. The content provider, all that. These are driving These are one of the key drivers of DC growth. Like I said earlier in my presentation, our population will continue to grow, and usage of the mobile asset will continue to grow. As this continue to grow, the data that we generate will continue to grow, and we need to keep this data. We need to keep them safely. The other thing again, the Internet of Things, artificial intelligence, the AR and VR, these guys consume a lot of data. Now, through Internet of Things, you generate a lot of data, and this data needs to be warehoused. Then the last on my presentation sheet is increasing cloud adoption. So this too is one of the key driver of DC growth. Next on my presentation, I said earlier talked about reliability of data center. And I talked about that according to Uptime Institute, we have tiers of data center starting from tier 1 to tier 4. Why tier 1 is the least reliable, why tier 4 is the most reliable. For tier 1 data center, according to Uptime, and after this, I want us to judge the data center we have in our respective home, in our respective office, and our respective organization. According to Uptime Institute, for you to have a tier 1 data center, your availability for annual availability should be 99.671%. That is, you are only allowed to go down 28.8 hours a year. That's when you are allowed to go down. That is, you're only allowed to experience a minimum downtime of maybe a day and maybe 4 hours in a year. Why for you to have a tier 2 data center, and this is typically recommended for small business because it has a single part of power and cooling, no redundant component. The tier 2 that you require for a data center to be qualified to call it tier 2 data center, you require a 99.749% availability. That is, you're allowed to go down 22.7 hours in a year. This too is recommended for small business, single part of power and cooling. You have some level of redundancy. In most organizations today, this is what you have. But still, you find out that you still go down more than this. And that takes us back to what I talk about processes. Find out that why most organizations, even despite having this infrastructure in place, they still experience multiple failure because most of them does not have the required policy, process, and procedure that governs their operation. Because another thing for you to build the infrastructure, and another thing for you to be able to manage them effectively. Now, the third one is tier 3. For large company, this require 1.6 hour downtime in a year and require 99.982 availability. This is the data center that I manage. We are running a tier 3 data center, though we run at tier 4, we operate at tier 4, but we are not tier 4 because of some certain limitation. But what we try to do on some of our critical infrastructure like power and cooling, we try to build tier 4 redundancy because we know this is key to our business. So we try to build tier 4 redundancy, even though our data center is certified for a tier 3. Uptime Institute, these are body that certify data center. They certify you based on once you meet the required condition, then you have been certified. Then the top of all this is tier 4. You only require 25 minutes downtime in the entire helm. Yep. So why do I need to build all those redundancy in my data center? I do that because two major things we watch out for in data center. You want to continue to run, or maybe things that we watch out for. You want to continue to run, and again, you want to optimize. You want to optimize your operation so that you can make more money. Because after you've built, the next thing is how do you run your facility so that you run optimally, so that you don't have downtime. Because when you run optimally, and when you don't have downtime and you run optimally, it's fine, but you might not really be making, because everybody is in business to make money. You might not really make a lot of money from you. So you must run optimally. You must avoid outages, because outages very, 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 very expensive. And again, aside from the outages, your operational cost is very, 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 very key. Also, for those of us that have business biased, your EBITDA will be very, very high when your operational cost is low. So you try as much as possible to as long as you have cash, you have enough cash collection, and you try to bring low you have enough revenue, try to bring low your operational cost, then you tend to make more profit. So these are things that businessmen look at. So you try and to make sure that your operational cost is as low as possible. And one of the ways is to run optimally and prevent outages. Now, from Steel Uptime Institute, these are major causes of outages. As far back, the last research that was done in 2020. As we can see, the survey showed that on-site power failure is still one of the biggest causes of significant outages, accounting for 37% of the outages. And the next is software and IT system issues. That is network issue. And again, the network issue is next. So over time, Uptime is to expect that more outage will be caused by networking and software and fewer by power, because people are beginning now to build a lot of redundancy into their power system, into their power network. You get more reliable source of power. You go into partnership arrangement with key power providers. So with that, in no time, we'll be able to overcome the power issue. Like the data center that I manage, power is no longer an issue for us. I can boast of about 23 hour a day supply from EKDC, where in my data center today. How are we able to achieve this? We have to invest in our own power network. We build our own power system from the substation, the Aja substation, and we build our own dedicated power line to our facility. So there is a dedicated line. I have my supply 33 line directly from the substation to my environment, and I reticulate at 11 kV. So minimal human intervention is a dedicated line. So minimum of 23 hours a day. So to a large extent, I've been able to solve this. But the other problem that are still glaring that might cause outages, which we would need the help of maybe the artificial intelligence and Internet of Things to help solve. So still on outages, what are the costs of these outages? According to their research, they said the cost is going up. Now, if you look at what we have here, 2020, and if you look at 2020, sorry, how can I put this? Okay, so if you look at for 2020 and 2019, the cost of outages is increasing. And with over half of who had experience, over half of people that have experienced these outages are saying it costs more than, for each of these failure, cost them more than $100,000. And in addition to this cost, we have lawsuit and financial adjustment increasingly common. So let me bring this even home. Let me bring this home. Now you can imagine today I have an ecosystem of banks in my data center. If I'm down today, you know what it means? Maybe let's assume I have 5 banks and I'm down today. That means all the 5 banks will be down. And when all the 5 banks are down, let's, for example, maybe the banks has each of them has 300 ATMs. So 300 times 5, that's 1,500 ATMs are down. Now you can imagine when an ATM is down for maybe an hour, financial loss for that financial institution. So the cost of outages is very, very huge. This is not even what you want to look at. It's not what you want to look at. Aside from even the ones that you can account for, what about the residual impact? What about the residual cost of this outage that you cannot even, that you can't cost? What about somebody that's willing, that have somebody critical in the hospital and need to just withdraw money, somebody going, the last guy they want to withdraw from the ATM, for him to visit the ATM, he cannot, he's stranded, you know? We have multiple of that. So the cost of outage is very, 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 very huge. It's very, very huge. So we need to do a lot in this space to ensure this is being minimized. We're doing a lot, and a lot still needs to be done to ensure that this cost, outages generally, is being minimized. I'm sure the next slide will interest us. The next slide talks about the human factors. The human factor. Now, if we are to consider the high and growing cost of outage, which is often in hundreds of thousands, investment, Internet of Things, artificial intelligence and machine learning to help provide prompt visibility and control with limited human interference will ultimately provide a payback. Now, what am I trying to say here? Now, when you look at these outages and how these have cost us, and look at what human contributed, the contribution of human to failure. Now, this is another survey that was carried out by Uptime Institute. Now, remember when I was talking about the critical success factor, I made mention of policy, process, and procedure. Now here, 57% of the failure, they say the data center staff execution, failure to follow procedures. The failure to follow procedure were responsible for 57% of the failure that most data center has, according to this research. And again, the next one again is incorrect staff process and procedure. That you don't have correct process and procedure in place. The next one is in-service issue. That is inadequate maintenance, equipment adjustment, inadequate maintenance or equipment adjustment. The next one is installation issue, insufficient staff, preventing maintenance. That is frequency issue, preventing maintenance frequency issue. How often do I do this preventive maintenance? And data center design commission issue. These are related to other human error limited. Now, if you look at this, most of the issue here is centered around process, procedure, and policy. And this we can leverage on artificial intelligence. We can leverage on machine learning, leverage of Internet of Things to help, improve on that. Procedure, once you get it articulated and programmed in a system, you do it more often. You all agree with me, machine will be more accurate than human. So the frequency issue will not be an issue. All those failure at maybe human error, unwilling to follow procedure. Once you have programmed machine to follow a particular procedure, the machine will definitely do that. So with that, we'll be able to, limit and reduce most of these outages that we have today in the industry. I'm posing this as a challenge to our scholar in the academic world. A lot of big companies are trying to do things in this space. Some build a standalone solution. A big player like Schneider, like ABB are trying to do an enterprise solution in this space. But I tell you, getting them is very, very too expensive. We can look at something local that we can, that we can develop, that we can customize to suit our own environment, and that will provide an immense opportunity for us in the future. There's one other unknown names, but they're big. They're doing something pretty well. I call them Kentis IoT system. That is KENTIX IoT system. These guys, they're doing a lot in this space, and from research that I have done, what they've done has saved a lot of small data center a lot of money. We can do a lot of things in this space. We can build a lot of things in this space because I tell you, this is a major issue and is what anybody at any point in time we embrace once you have a suitable solution for them. In my data center today, we're doing it and we'll continue to do. We're growing in it. There are some aspects that we've automated, that we've applied artificial intelligence to do something, especially in the area of my cooling, in the area of my monitoring, so at least we're introducing that gradually, but still a lot needs to be done in this space, most especially the changing dynamics of the data center. Like I said, in no time we have a more miniature and a smaller footprint data center with more complications. So at that time, we need a lot of this learning, a lot of this intelligence to be able to provide the needed support. So having said this, I need to optimize my data center. And how can I optimize this data center? How can I make it look more better? What can I do to optimize? What can I do to optimize my data center? Like I said, I don't want to bore with mine. So let me just go straight to what I have. The first thing I want to talk about here is data center. I'll talk about what we call power utilization efficiency. I said earlier, operational cost is key to me as I operate my data center. So I want to find I have the power, but again, I want to use this power optimally, efficiently as possible. I want to eradicate. I want to eradicate wastage. I want to eradicate what I don't need, and to do this, I need to be able to ensure that only the power that is required is being supplied in my environment. A lot of factors will be considered here, even in your design. Maybe when you want to buy, put in what are the power factors of the device I'm buying. Like, for example, I want to buy a UPS now. At least my preference would be a UPS with power factor of 1 compared to UPS with power factor of 0.8, because definitely the power consumption, the power efficiency of the guy with the power factor of 1 is much better than the one with the power factor of 0.8. Those are the consideration those are things we consider at the point of design. Now again, at the time in operation, a lot of things you consider. Your cooling. We make sure that the cooling that you have at the data center is just efficient, is just optimal. For example, my inlet, according to ASHRAE, technical committee C9.9, ASHRAE TC9.9, the inlet acceptable temperature within the data center is between 18 to 27 degrees centigrade, while my humidity is between 20 to 80%. So within this, I must manage. The more higher I can and keep my data center running, the more efficient my data center will be in terms of power. So I need to ensure that I'm not cooling my data center too much. If I go to some data center today, everywhere will just be cooling. The equipment does not really need that chill. The experience we used to have those days, that when our data center was very, very chill. We don't need that. But when you do that, you make a lot of wastage, and that is going to cost you a lot. A perfect PUE should be 1. That is, the power utilized by your IT equipment and must be equal to the total power of your entire infrastructure in the data center, and the power, all the power of your AC, your power of your cooling, your power of your generator, everything must equal the power of the IT equipment. That's when you have the most efficient data center. That's PUE of 1. You hardly find this, but most modern data centers today, they are getting close to maybe 1.2, 1.3. Presently, my efficiency is at 1.57, which is relatively very okay in this part of the world. That is, I'm using 1.75% of facility power to power my IT load, which is a good efficiency for those that knows about it. So what am I trying to say here? I need to leverage more on artificial intelligence to ensure, leverage more on Internet of Things to ensure my cooling at any point in time is optimal. Like I said, I can operate between these set points. There are a lot of technology we build into this, like you having a containment where you contain all your cooling here. And before now, what we do is that we have grid, damper grid. When you go, you can change. When you want to reduce the cooling, you have a grid with damper. You open or decrease to increase the cooling. That's what we do. That's what many people do, and that's what many people still do. But you can leverage artificial intelligence here, where you have a sensor, machine learning and artificial intelligence, Internet of Things, where you have sensors in your data center that sense, the cooling requirement at a particular time, and that sensor now, when you've learned over time, that sensor now talks to your cooling, either your CRA or your CRA unit, and tell them to either increase or lower the speed of the fan at that point in time, either increasing or reducing the speed of the air that you're blowing into your cold eye at any point in time. And by so doing, you'll be able to, make sure at any point in time you regulate or you optimize the cooling that you are sending to the equipment at any point in time. So we've leveraged AC here. We've leveraged artificial intelligence with Internet of Things, but again, like I said, a lot still needs to be done in this space. We still have a lot of manual intervention in controlling this. We have a lot of manual intervention in controlling this, but there is enough work for the researcher to do here to ensure at any point in time, in terms of maybe the cooling, the power. So a lot of things have been done even around power. Aside the energy saving bulb, you have when motion sensitive bulb, where at any point in time, once it's only when it senses that there's someone inside the facility that the bulb comes. The bulb comes up, and again, depending on the type of intensity that you need per time, determine how luminous the light will be at any point in time. But more still needs to be done in this space. Like I said earlier, AI, the application of AI is changing, and you can see it's transforming every walks of life. We in data center is presently being used to monitor virtual machine operation and idle or running mode server storage, networking equipment to coordinate cooling load and reduce power consumption. Now, this is what I just explained now. And again, like I said, the dynamics of data center is changing. We're going to have more converged infrastructure. Now I have a lot of servers, I have a lot of containment. I can even still manage the manual approach. But with time, when we come to the dream world, where we have our cloud provider as our customer, we need more of intelligence to be able to support them, more effectively. I wouldn't know if I'm to read this or just continue, because I really want to also have time for discussion. Like I said, these slides are available. You can get and read up most of this write-up. Just try to say some things about how we optimize with the use of Internet of Things. Create new opportunity to optimize data center infrastructure management. And like today, in my environment, I use a product from Schneider. I use their DCIM solution. So with these, I have a lot of sensors where I can remotely monitor the operation in my data center. I don't need to go physically. I know what is going on. And again, one thing this helps me, I can spool historical record, I can trend, and I can plan ahead, so I know what is expected of me. Again, the next day we're going next now, we want to look at how, based on our historical record, how we can build a lot of intelligence into what we have to better support our customer in the future. That is the next phase of our optimization. What we do now, we get those data, we do some minor optimization, we do some minor regulation of fan speed, but more deeper, we're looking at how we can leverage more on artificial intelligence to further optimize our data center operation. And like I said earlier, when you look at, the initial cost might be huge, but when you look at the outages and the cost saving that you have eventually, I think it's just better to invest in this latest technology. These are some of the applications in the data center. I use it for, like now, this is what I do. I measure temperature and humidity monitoring. I use Internet of Things to, to do this. Like I said earlier, my data center run 24/7. So I use temperature and humidity monitoring. I do that today. I do remote monitoring where I can monitor all my infrastructure, monitor all my UPS, monitor everything. Again, it makes it more reliable. Just for example, if my generator is not ready, I got an alert at my BMS desk to say, okay, generator is not ready. You can imagine if you don't have this information and there is an outage and generator is not available to run, then definitely there's going to be an outage. So the investment in this solution was the why, because proactively, you know what is going on in your environment and you can proactively plan. As long as our process and procedure are well followed, we have no surprises. For you to have surprises in our environment is very, very minimal. I hope I'm not boring us with my too many stories. The next one again is the leak detection. Water and data center is key. So you don't want water to destroy all your infrastructure before you know. So with Internet of Things, we could see that, okay, there is water, and because there is water, we can easily, immediately there is one single drop of water, the sensor will pick it and report remotely. So you can easily go and salvage the issue before it becomes a major issue at the DC. Next is indoor air quality. We monitor this because it's key. You have to keep the equipment and servers safe. So the quality of air that we have in the data center is very, very key too. We use Internet of Things to do this. Next is security. Internet of Things play a major role here too. So finally, as I conclude, I have it here that Internet of Things can help save up to 66% of edge data center expenses. Smart sensors save costs in remote operation of data center. With Internet of Things, we work smarter, not harder. That's Internet of Things. You can work smarter, not harder. We establish a new remote work task force and mitigate risks as they arrive. You can read that up. There is a reference there for those who be interested and want to read that up. And again, according to Gardner, say IoT play vital role for lowering energy expenses, which are the data center largest potential operational costs. Like I said earlier, once you can reduce your power costs, once you can reduce your energy costs, like today, energy costs form about 80% of my operational costs. 80% of my operational costs. So you can imagine if I can save 40% of the operational costs, you see how good that would be for me. So data center frequently overcool their facility by several degrees merely to be safe. For every degree of increase in the baseline temperature, environmental sensor reduce. For every increase that environmental sensor reduces energy expense by, for every increase, the environmental sensor reduces energy expense by 4%. For every degree of increase, as we increase, maybe from 27 to 26, or maybe then you are saving like 4%. You can read that up to in the link that I shared. And as I round up my presentation, owing to the increase in data center usage and management needs, data center will need to prepare for big changes. Security and privacy will certainly be a major demand. The convergence of data usage and management needs will require an industrial-wide transformation. Data center need to upgrade their network for the IoT revolution. Data center will need to boost the number of connections and overall speed in order to keep up with IoT, especially the 5G IoT. The increasing need of data center storage could potentially require data centers to reconfigure their server farm to handle wider and more diverse data flow. At the same time, the data center industry may need to invent more robust load distribution strategies to deliver better data center management for the Internet of Things. Then finally, thank you. So that is all for me. I wait any question from our audience. Thank you. Question from the audience, please. Response or other response question from the audience, please.
Thank you very much, Engineer Deoti. Do we have questions? Can I see your hands? Okay, I have one here.
I do have a question too.
Do we have online?
Yes,
Yeah, I think there's
online.
some question on the chat. There's some question on the chat.
There's an online question. I also have a question.
Okay, we take the online one first before we come to the physical session.
Okay. Can I go ahead?
Please go ahead, please.
Engineer Wole Adeoti, thank you very much for your wonderful presentation. I have a couple of questions to ask. Some may be kind of question, suggestion, or analysis or something of that sort. You know, so at what point does a physical data center become a cloud storage, for instance? Because I mean, like if we're talking about cloud, eventually we're going to have to store these things, whatever it is we want to store, on some server somewhere that we may not know where the server or whatever it is will be located, but there are physical servers actually that we term as cloud. So at what point does a physical data center become a cloud storage service? Can you hear me?
Yes, I can. I think let me just take that first before other question.
Okay.
Oh, okay. Yeah, good question. You know, cloud today has become a buzzword, a bizarre word that everybody just used. What was a cloud? Again, to many people, you think maybe, okay, this data is being stored somewhere in the cloud. No. Your local data center could be your cloud. Cloud is just more like a remote storage that is not local to you. Like even today, you find out that some organizations, they have their own local cloud where they store their cloud is just like a warehouse, a storage location. I get me. So it's not there or there. You can't say this is a cloud to so many people. Cloud could mean different things to so many people. Right. For example, now you could have a local cloud in your organization where you store your maybe your share folder and you store it locally in your organization. It's your cloud. Right. At the same time, that cloud again could be offsite. You know, cloud could be on-site. Let me just use that word. It could be on-site or off-site. Like when you have maybe you like the Amazon or Google of this world, they are off-site cloud. I get it. Right. And again, it could be local or remote. I don't know if that answered your question. That does. Okay. And a question too, if you don't mind. Right. The environmental condition within the data center, for instance, at the moment, if you use normal air, I mean like air conditioners to cool the place, at some point the condensation will take place such that you begin to feel water droplets form on server panels and so on and so forth. Is it possible, is there a consideration for a normal air airing system for data center? Is that a consideration? Like something like maybe you are using hydrogen or a mix of hydrogen and something, excluding not entirely air, and then is there something like that, or am I missing something? You are not. It is part of our own world. The cooling unit the cooling infrastructure that we use in our normal house that generates humidity is not being used in the data center. Cannot be used in the data center like ours. Right. You can use it in your own local data center, but in a data center like ours, you cannot use such cooling units. Our cooling units are more precision. Now, like I said earlier, according to ASHRAE, the minimum level of humidity that is allowed in the data center between 20 to 80%. Right. That's what is allowed in the data center. So the cooling unit that we use is not the one, because again, you know, the heat that you generate, it just is a unit that generates sensible cooling, because the heat that your IT equipment generates are sensible heat, are not latent heat. So the cooling that we use in our data center are cooling that that provide sensible cooling to just suppress the cooling that is generated by the IT load. Yet, from time to time, we have interference with the ambient temperature.
Right.
I get it. With the ambient temperature, my time to, you know, introduce some level of negative pressure into the cooling system. Then again, the cooling units that we have, most of them have dehumidifiers.
Okay.
Yes, they come with dehumidifiers. So they come with dehumidifier on their own. And these things are just, these are not what you do and do manually. These are part of the intelligence again that we build into our system.
Right.
Based on depending on the demand at that point in time, dehumidifier comes up on their own, do what they need to do, and just go down again. You know, again, that helps us to manage the power that we consume. Because if you just leave a dehumidifier that you just go and open, just go on your own, you don't control it. But this one is being controlled. They just check and look at, okay, I need this to come up now. It comes up, does its job, and on its own without human interventions, and goes up. So with that, we're able to manage the cooling. We're able to manage the environment without those externality factors.
Thank you very much.
Thank you very much for the question and the answers given. We want to come to Afe Babalala Paul for the next question.
Good morning, sir. Thank you very much for the wonderful lecture. I think I enjoyed every part of it. So I have, my question goes thus. What's the percentage estimate of OPEX that goes to cooling the data center? That's number one. Then a follow-up question to that will be, considering our weather in Nigeria, is it profitable to run a data center as compared to running it in the Western world? Then a follow-up question to that will be, considering weather, wouldn't it be more profitable to be situating data centers in areas like the Mambila, which are cold throughout the year? Because most of the data centers, like for example, Rack Center and May1, are all located in Lagos. Thank you, sir.
Yes, thank you. If I get the question very well, the first one you're talking about what percentage of the OPEX is cooling GOPing. Then you're talking about locating data center. It's not better we locate the data center in the cool region. Did I get the question, or you still have you have another one?
Okay, so you got the first one very accurately. The second one was considering whether is it more profitable to run in Nigeria as against locating it in Western world that is usually cold, places like Canada. Then a follow-up to that was that if we are running it in Nigeria and we are agreeing that colder regions are better, why not locate in places like the Mambila that are closed throughout the year, instead of most people jostling for location in Lagos?
Okay, so let me start from, I'll take it from the last question. Now, locating the data center is very, very critical. Location, when you want to set up a data center, location is very, very, one of the key considerations in setting up a data center. Because one, who are your customers? How free can they access your data center? How secure even is that your data center? How can you boast of security of your data center? So you have to weigh most of these considerations to determine where you eventually. Okay. And again, connectivity is very, very key. Now, in this part of the world, Nigeria, for example, now power is key. Power for you to locate it, for you to locate the data center, power is very, very, because power is a key critical infrastructure for a data center. So to set up a data center, you have to find a way where you can easily get this power that you need. These are not small power. These are big, heavy power. You have to, if you can locate in the place, fine, the place is cold. that the place is good, I won't spend money on cooling, but how will I generate power? The cost, all these costs play out. You have to do your visibility studies, and I believe that is being done for everybody trying to set up a data center. They do their visibility studies, put all factors into consideration, and based on that, they now take a position where to locate the data center. And again, proximity to connectivity. I get me. Like ours, for example, now we position our data center where we are because we want to be close to network connectivity. Like you are aware, if you know about Mewan, we are one of the cable provider in this country. We have a cable direct from Seychelles, Portugal to Nigeria, and our cable landing station is right there in Nigeria. So we know the role that cable will play in data center business. So to us, and again, we have our vision. We want to build the right ecosystem in West Africa. And for to build that ecosystem, cable plays a major role. So for that, we have to situate our data center close to where we can have easy access to the cable. That is one of the considerations. Then again, power is another consideration. Now, most of my competitors today, they blow generator 24/7. And that will go a long way, eating their operational costs and making them more expensive and making them not that profitable. Because when you keep burning diesel, aside from the cost of diesel, the mechanical cost of repair or generator and things like that, those costs are very, very huge. So it's a key consideration. Like ours now, we position where we are because we want to be close to the substation, the Agile substation, where I can run a dedicated line. And I know in Nigeria, since the government is not providing power, I need to provide the power myself. So if I can solve power problem, to a large extent, I've solved my problem. So again, there's no direct answer to maybe where you locate your data center. You consider your critical factor, do your visibility studies based on what you have and based on what your visions are. Then that will help you to situate your data center where you want to situate. I just tell you two critical factors that make us to situate ours where we situate our own. Then in terms of the cost for cooling, the cost for cooling determined is very huge. I get it, is very huge. But again, you can't just bring it out to say this is the percentage of cost for cooling. Among my power, the only thing I can tell you that like I said earlier, my operational cost is about 80% of my power cost is about 80% of my operational cost today. And cooling, definitely, in terms of power consumption, cooling takes, if not even 80 or 90, it takes about more than 50% of total power consumption, about 60 or 70% of total power consumption. So what that tells you is that the cost you are paying on power, about 60% of it would definitely go for cooling. I don't know if that answered that part of the question. Now, again, comparing Nigeria and other parts of the world, maybe if we are profitable or not profitable, these words are relative. You can't say if we are profitable. We have a lot of indices that we look at the factors that affect us in Nigeria is different from the factors that affect them over there. So the most important thing is that every organization have their cost model, have their financial model, and want to be profitable at a particular year. I might not be able to tell you now because, like I said, it's relative. Either we are profitable or we're not profitable. What I can tell you for free is that most of these big players now, all of them are planning to come into Nigeria and to come and own a data center. So if the business is not profitable here in Nigeria, I don't think they will want to come. Most of them are coming now. Not until now, we have just 3 data centers in Nigeria, Mewan and others. That is Mewan and others, which is your health center or MTN. But today, we have a lot of these big players now trying to come and have their own data center in Nigeria. So if the business is not profitable, I don't think they will want to come. Thank you. Hello?
Yeah, I don't know. I have another question. I don't know. I don't want to steal the question time. But it's okay.
Question. Actually, we have another person who has been raising up his hand.
Please. Yes.
And
I will wait. Can I ask my question?
Please go ahead.
Okay. Thank you very much, Dr. Mr. Adioti. My question is, actually, I have 2 questions. One is, You mentioned in the renewable energy, the energy supply that you use for your data center, and you said 2 to 3% of renewable energy. I see that's quite low. Is there any hope for renewable energy contribute to a substantial portion of the energy consumed by the data center? That's one. Then secondly, the other question is, how do you quantify the last mile connectivity to the residential houses and the SME customers? Because these days I see many fiber optic cable being laid in the last mile to residential houses and all that. But these days, because of the problem of road construction, things can really be disrupted. And if you keep splicing the cables every day and then, I don't think that will really be cost effective. So what do you see to those two areas? Thank you very much.
Okay, thanks, Engineer Francis. Now, the first question about renewable energy, if you follow my presentation very well, and like I said, we have a lot of engagements going on because, again, for the big players coming from OBES, this is one of their key considerations. They want to see your green footprint. So we are having a lot of engagement with a lot of organizations to see how we can increase our green footprints at the data center. And the last engagement, we're looking at generating close to 500 kVA at the moment. We have some support vendor we're working with on that at the moment. And the plan is before the end of year 2020, we plan to achieve that. That's our target. We're trying to see how we can do at least 500 kV, because again, we have, our data center is an existing data center. There are a lot of restrictions in terms of space. We can only make use of available space. For those building now, they factor that in their design, even as they build. So that has been factored in the original design. So it's easier for them to adopt the green technology. But for us that have been existing, we're trying to see how we can incorporate that. But as a percentage, we know we're not satisfied with that too. We're trying to, we're trying to see how we can increase our adoption rate on that. But again, I might want to challenge us again. One of the things that, we've had this long time. One of the reasons why we've not really done it, because again, it's too expensive. We're only just doing it as, we're not doing it because it's cost effective. But again, you should know that we are in business to make money. But when you have an alternative source, and even the green power is coming as a cheaper alternative, the adoption rate will have been very, very easy. But it's quite more expensive compared to even when you look at what you put into it, your initial cost of investment, what you put into it compared to what you pay to get power today, is quite very expensive. So again, I want to throw this out as a challenge for as many green power provider. Let's look for how we can get a more cheaper alternative for this solution. If it's cheaper, if we can benchmark the cost with that of maybe the utility supply, why not? We are in business. People are in business to make money. So the adoption rate will be much faster. The reason why it's difficult now, when you consider how much you're going to invest in developing, coming up with maybe a solar plant, the green power compared to what you're paying on power now, this is going to eat into our bottom line. So many of these owners, they've been skeptical, they've been reluctant. I said maybe they are forced into like this, and just like maybe like becoming more regulatory. They want your data center to be green and things like that. That's even why many people will be looking into that. Aside from that, in terms of being competitive, in terms of being efficient, in terms of cost, people might not really do that. So this is the key consideration for you guys that into green power. Get a more cheaper solution, and you see the adoption rates skyrocketing. Then on the other, your other question about the last mile connectivity. My company, we don't do last mile, we do wholesales. But even we sell to most of these people that do last mile. Because you can't be competing with your customer. Or else then you're going to push them, you're going to move them out of business. So We don't do that. If we want to do that, we do that on the special cases. We don't put it to the face of the customer, last mile solution. But even the same problem they are experiencing, we experience too in our core network. But what we try to do to minimize and manage this is that we do more of engagement. We do government engagement. We do more of contractor engagement. We have licensing officers along most of the major roads that whatever anybody want to work, our guys, we need to be on ground because we know our routes. So our guys, we need to be on ground to, to guide and direct those guys. We know where our cable is or where our cable are, so that we tell them, okay, when we get to this point, and again, if we need to relocate temporarily, we relocate for them. A key point is when they were innovating, when they were constructing this Lekki Ekpe Express Road, a lot of people experienced a lot of that, and though we experienced too, but ours was minimized because we engaged well. Most of these key stakeholders, most of these contractors, we engage them effectively, and we work closely with them to mitigate against this crisis. Thank you.
Thank you very much. Well answered.
Thank you very much, Engineer Deoti, for that wonderful presentation and the answers you've given to the questions. We really, really appreciate your time. Thank you. Can you please jam your hands together for Engineer Adeoti? I think we have to wrap it up here and move to the next section on the program.
So sorry, sir, before you round up, I would like to acknowledge some of my colleagues that helped me put this write-up together. They did a wonderful work and some wonderful research. Sorry, can you just come and say hello to them? Can you come? Sorry, I'm in the office. Amarachi, can you just come? Tunde, can you come? So that you can just say hello. And there are some of my colleagues that helped me put this together. It's not just me. I just say hello to everyone. Hello to them.
Hello, everyone.
Yeah.
Hello.
Thank you very much.
Hello.
Thank you for a good work. Thank you for a great work.
Okay.
Yeah. Yes. Okay. So thank you so much. Thank you, sir. And thanks. And always available. I'm more than happy to come back again in whichever level, whichever class you want me. And I appreciate you. Thank you.
You are much appreciated. Thank you. Thank you. So we move on to the next segment. We are going to have paper and poster presentations. But before we do that, we'll have a short tea breaks for the next 20 minutes. The next 20 minutes. So we are coming back here exactly 12 noon to start. 12 noon. Thank you.
Off the video. Stop the video. Did you cancel it? Question. Just check. Just check. Twice. Yeah, you are live. Just do it like that. Okay. Let me get it. Now, which one you want watch?
No, I don't want to check around it. Like, I just
You want check that? Stop my. Hello? Yes, everybody's on.
Good afternoon, everyone, ladies and gentlemen. We want to start the second segment, which has to do with the paper and poster presentation. So our online viewers, please, it's time to come back from the tea break. I leave it open now for the chair of this session to take over. Thank you.
Okay. Good afternoon, everyone. I would like to leave a general instruction so that we will not take much time. So each presenter has 10 minutes. Each presenter has 10 minutes, and then we are going to ask questions, and we'll use 5 minutes. I would like to please plead with those that will ask questions to make it brief so that we can move on to the next presenter. So I'll call on the first presenter, Glory Ugegbe, to present with work titled Error Analysis of Radio Frequency Scans at High Frequency, Very High Frequency, and Ultra High Frequency.
The head of department, distinguished lecturers, Department of Electrical Electronics Department, University of Lagos, my fellow students, good afternoon to you all. My names are Glory Ugegbe Uzazubola, and I'm here to present a paper titled Error Analysis of Radio Frequency Scans at High Frequency, Very High Frequency, and Ultra High Frequency range. And you agree with me that frequency scans measurements are very useful when it comes to radio frequency interference detection and also mitigation. Basically, when you can use as a detection tool and also a mitigation tool. It also helps frequency planners in planning the usage of their frequency. It also is also useful for network deployers in deployment of microwave network. It can also be used as a troubleshooting tool when you are troubleshooting microwave. And it can also be used for preventive maintenance when you need to prevent your microwave from interference. Meanwhile, this paper was as a result of the frequency scan that I carried out in an enterprise customer site for Port Harcourt, River State. And the facility actually was owned by Chevron Nigeria Limited at Orne. So that was where I had to take the frequency measurement that I used for this paper. Basically, the experimental setup is what you can see there. We have the antenna there, which is connected to a low noise amplifier using our RF cable. Then feeds it in as an input, and that output goes to a spectrum analyzer, which is the main device
and the main measurement equipment. Then the output of that spectrum analyzer is fed onto a laptop for the extraction of the readings and the results. The essence of the ROS cable, as you know very well, is to be able to at least transmit the ROS signals, pass through an amplifier, and goes through the spectrum analyzer. The spectrum analyzer is set at the accepted frequency that you want to measure. Like I said, the measurements are of the high frequency.
Hello, please, can you page the slides?
Spectrum analyzer.
Please.
So you have to set the frequency. The range is set. For the high frequency, is from 3 megahertz to 30 megahertz. Then for the very high frequency was from 30 megahertz to 300 megahertz. And for the ultra high was from 300 megahertz to 3 gigahertz. And though the background, because these are the raw readings from the analyzer, they are raw. The background is dark, so you may not be able to see the frequencies that we track. But for each of them, the frequencies we track against their individual power. This first one here, this first one is for the high frequency. The second one there is for the very high frequency, and this one is for the ultra high frequency. If not for the back, and you will see them, you see the movement you see there, and these are the power levels, and these ones represent the frequency side. The system model for this error analysis, which is statistically done to be complete, and for it to be possible, I have to use a MATLAB tool. And for you to successfully do that, that means you have to recreate, these readings using MATLAB. So that was what I used. And for you to do that successfully, you have to first of all determine the sampling rate. And by doing that, you assume that the offset frequency is also the start frequency for each of the bounds, which is the high frequency bound, the very high frequency bound, and the ultra high frequency bound. And we have the input signal is given by this equation. Small f(s) equals to 2 times f of x, big letter, where the f of x, big letter, stands for your frequency span, for us to be able to get the offset frequency. That led us to the second equation, because I have to determine the power spectral density from the first equation. Then from the first equation, you will agree with me that from the analyzer readings, they are all sine waves, which have trigonometric functions in them. So for you to do the sampling, they are continuous variable, continuous functions. So he gave us this equation 3. Equation 3 emanated from there. Then for you to be able to calculate or to generate the signals at different frequencies for the bound and the polarization, we use equation 4. Now, we have to, because it's a statistical error analysis, standard deviation is key. So for us to get the standard deviation, we have to first of all look for the power of the signals in respect of standard deviation. And that led us to equation 5. Then from equation 5, we're able to extract out a formula for standard deviation. Now, the first stage or first step of getting this analysis done is to replicate the spectrum analyzer reading on a MATLAB environment using those equations. And that was where I generated this for the high frequency scan. And what I have to do to differentiate them I use colors.
Hello, please, we can't hear anything, please.
Now, is after extraction, we do what's called denoising. But this paper does not carry the denoising part of it. The denoising part of it was extracted from this paper. But denoising was done after proper filtration. And that gave us a better statistical understanding. But that was not part of this paper. It's on another paper that's under review for publication. So I didn't include it on this one. Yeah. Okay, and the second one. Then for the Gaussian distribution, the noise, we have white noise. It's white noise. So using MATLAB code, we're able to generate the PDF on the histogram. Yes, on MATLAB too, yes. Exactly, yes, using the major data. Thank you, sir.
Yeah, good afternoon, everyone. Standing on our existing protocol. My question goes to the department. This is the theory aspect. The question I want to ask, do you have well-equipped laboratories and good equipment for this? That's the question I want to ask. All what is displayed, do you have it in the laboratory where the practical aspects can be carried out? Thank you.
Thank you so much, ma'am. I have to answer that. We have the electronics lab and the telecom lab. In the lab there, they have spectrum analyzers there, and antennas there, and we have amplifiers that can do the same measurement. But all of the equipment is that I use for the measurement from my office that I took to do it. But the lab there, that they have all these equipment there. Thank you.
Okay, those online, please. Do you have questions? Questions for our online participants? Okay. Rachel. And it's presenting distributed generation system, opportunities, challenges, and mitigation techniques. So we have 10 minutes to do that. And questions, please make your questions short. Thank you very much. So you can start.
Good afternoon, everyone. Good afternoon, my lecturers, staff of University of Lagos, and fellow students. My name is Dennis Ocho. And I'm presenting a paper this afternoon titled Distributed Generation System, Opportunities, Challenges, and Mitigation Techniques, a literature review. All right, and this is my presentation outline. The aim of this presentation is to review existing studies on the opportunities, the challenges and mitigation techniques associated with distributed generation systems. Now, a distributed generation system is a system of power generation whereby power is generated and distributed without involving transmission facilities. And what is inspiring this topic is the environment where we stay in Nigeria, where power is actually a burdensome challenge. So distributed generation is a technique that works in many countries of the world. Without, it comes with disadvantages and also the challenges, and that's the whole essence of this paper. Now, the traditional power system, like we know, the grid system, it transmits to through transmission lines to a long distance. It utilizes transmission lines, and in the process of power transmission, because of the effect of length of the power facilities, we experience energy losses. And as an active player in the sector, I can tell that there is so much loss in our system here. There's so much loss, energy losses, because of our mode of energy transmission. Now, with distributed generation, the losses are reduced, power reduced, energy wasted is reduced, and because of that, efficiency is increased. Now, distributed generation comes with its own challenges. One of those is power quality. That is a measure of how good or acceptable the voltage is for the end user. As we might know, voltage is one of the essential parts of power, and bad voltage means bad electricity. Now, placement of the distributed generation or generators is also a major issue that should be addressed. The proper sizing of the generators is also one of the issues. Now, this is a block diagram of a distributed generation system. There is a grid there, and there's a point of common coupling. That is, there are events where, for instance, in the Nigerian sector, we can sell off or tie excess power to the grid if we have distributed generation in several corners of the country. Now, in the traditional system, which is the grid system that we know, because of the challenges, we have introduction of distributed generation will bring about these opportunities. Number one, improvement in the power quality. Now, improvement in the system reliability. Yes, we'll have more reliable systems. In our society, system collapse is a major phenomenon. And in this year alone, we have several system collapses. Now, with distributed generation, the whole system do not have to collapse. A portion can be taken out. Now, there's reduction in energy losses. There's backup power availability, reduction of peak power requirements. Because distributed generation uses a lot of renewable energy, we can store through batteries and then utilize the same power through inverter for the end users. Now, it alleviates congestion on the main grid. It eliminates the expenditure that will be required in transmission. Transmission takes a lot of capital investments, and this is one of the benefits that distribution generation does. It takes out that expenditure. Now let me run along. But here are the challenges associated with distributed generation. Power quality problems. Yes, the sizing of the generators and the placement, reverse power problems, flicker noise problems, interference with sensitive communication gadgets, and protective devices. And then there's a protection coordination problem. Because the generators are located close to each other or not far apart from each other, you will expect that fault current will be a major issue on how to deal with them to prevent taking out a large part of the power network. Now, here are the mitigation techniques. For power quality problems, now the power quality is a measure of how acceptable the voltage is at the end user part. Now, the power quality issues can arise right from the voltage wells and both starts and switching sources and harmonics. Now, the mitigation technique for this has been reviewed from several papers. Now, I did not include the names of the authors here for the sake of the paper presentation, but it's in the conference proceedings. Now, integration of storage systems like supercapacitor, boost voltage, and the flywheel and power conditioner can help us in dealing with power quality problems. Then neurophysical adaptive network for predictive operating of renewable units in distribution systems by getting the load margin to deal with operating systems. Because of time, I'll run along to other challenges and how to deal with them. Reverse power problems. Now, reverse power comes about when there are faults, and when fault happens, it travels in different directions. Now, to prevent this fault current from taking out a good portion of the generation of the power network, we have to solve this problem of reverse power. And authors have suggested that when we incorporate reverse power relay right from the initial design of the distribution system, distributed generation system, it takes a lot of this reverse power problem. It was proven that it minimizes the negative effects of reverse power in the event of fault. This was tested on the IEEE 13 bus network. Flicker noise problem. By employing the look-ahead control algorithm in a perfectly tuned automatic excitation regulator, by incorporating automatic speed regulator in the distributed generation unit turbine, it fully eliminates the flicker noise problem. Now, there's the challenge of interference with sensitive communication gadgets and protective devices in the vicinity of the circuits of the distributed generation system. This particular challenge can be taken care of by incorporation of power enhancement devices. Examples are the static bar compensators, transient voltage touch suppressors, harmonic filters, and the SCADA system, which is a real-time monitoring system that can be used to restore a failed portion of the circuit to avoid a total shutdown of the entire system. Now, there are protection coordination problems. Protection coordination problems can be sorted by designing a scheme that compares the positive sequence current of the fault component at both ends for fault recognition in order to isolate the defective component, and also implementing a directional pilot protection scheme based on the positive sequence current of the fault component. As I mentioned earlier, faults are regular in power systems, and a protection system should be sound such that such faults should be mitigated and the portion of the fault isolated in order to prevent damage to the entire system. The tier optimization technique for placement and sizing of distributed generation. Now, the artificial bee colony algorithm, which is a population-based optimization algorithm. The job of this particular algorithm, how this algorithm works is that it finds the optimal location and size of the distributed generator in order to minimize the power distribution loss and equally enhance the voltage profile. It employs three phases: the employed B phase, the onlooker phase, and the scout B phase. Now, this particular algorithm was tested on 14 bus networks and as well as 57 bus test systems. Both were verified in the MATLAB software. There is another method that can be used for optimal placement and sizing of a distributed generation, which is the supervised big bang, big crush method. Now, because of my time, what the superiority of this particular method is that it provides a guidance table, and so it positions the method in the direction of an optimal solution. Okay. Let me go to the next method, the analytical method. This was tested on the IEEE 14 and 30 bus network. IEEE 14 and 30 buses respectively via MATLAB. Now, this involves very extensive mathematical steps that is used to deduce the expression for calculating the size of the distributed generations at two buses instantaneously. There's the cuckoo search algorithm. Now, this particular algorithm is inspired by a species of bird named the cuckoo. What's unique about this algorithm is that it has reduced number of constraints. It converges faster. The fuzzy logic algorithm, it makes use of a fuzzy interface system, and it contains a set of rules that is used for computing the DG placement of the individual buses. And what's unique about this method is that the newly obtained voltages and losses are to be used as input to the FIS system to calculate the DG placement index. There's the particle swarm optimization technique. Now, this makes use of optimal power flow, and it is used to determine the sizes of the DG unit. The power stability index, it centers around the most critical bus in the system. What's the most critical bus in the system? That particular bus, which is very susceptible to the stability of that network. And this is why we use this power stability index. Now, when you place multiple DGs, the subsequent DGs, or DG means distributed generation, the position is based on the effect of the first DG in the PSI equation. Now, the PSI equation is, okay, all right. This is the last slide, actually. Now, the PSI equation is what centers, this power stability index centers around. Now, the opportunities and challenges associated with implementation of distributed generation in power systems have been examined. Now, the challenges, they are not insurmountable. And that is the purpose of this paper presentation, to present reviews of several literatures and what they offered as possible solutions to these challenges. Thank you very much.
Thank you very much, Engineer Owoicho, for that presentation. So please, do you have questions?
Yes, I have a question.
Would like to take questions from...
Question, please. Please, we can't hear. Can you unmute the speaker, please?
Now, when you go to a distribution grid, the voltage magnitude of the three phases are usually not the same. So they are not balanced. And in that regard, when you do your modeling, there's always a second harmonic component in your power. And of course, there's a negative sequence component coming out. So in every distributed in every distribution grid, that's always a problem. So I know for sure that it's not only the positive sequence that you're going to get. The negative sequence will come out, and it's always significant. So how do you tackle that? Because what I see you mentioning is the positive sequence alone.
Okay, sir. Please, which slide particularly were you referring to?
Yes, I'm pressing that. After this, okay. We can see the negative sequences here. This is by incorporating reverse power relay. No, yes, yes. So can you go to the next slide, please? Well, okay, next one, please. Next one, please. Yes, stop there. Your last bullet. Okay, sir. I see positive sequence current of the false current. Okay, sir. This particular paper that was reviewed, okay, there were no references made to the negative sequences on this particular paper that was reviewed. And at the moment, sir, I may not be able to give an answer, sir. Yes. The negative sequence will come out because it's not balanced. You know, it exists. So it's always a problem. Negative sequence is always a problem to tackle with in the distribution grid. So I guess you should look at that also. Thank you. Okay, thank you, sir.
Yeah, my question, please.
Okay. Now the title I have here, I think it needs a little bit of modification. It says distributed generation systems, opportunities, challenges, and mitigation techniques. The way it looks here, it's like you're trying to mitigate generation system opportunities. That's how the title sounds. In fact, that's how it is. So you need to modify it a little. You can say distributed generation system opportunities. You can put a dash or colon. Then challenges of the system and mitigation techniques. So that makes it clear because the way it sounds as if you're mitigating the distribution system, the way it is.
Okay, I understand.
Okay, so that slight modification will make it clearer that you're trying to mitigate the problem. And then I was expecting more emphasis on the effect of the distribution system in actually supplying the power, because most of the things presented here are how the system affects other systems. But I was expecting something that will show how we can benefit more, and then how those things that stop us from benefiting more in terms of power system analysis. But I'm seeing more of interference. So I think emphasis should be laid more on that aspect, because all we are trying to get is a better system so that we can get electrical power in Nigeria. Because, and then this one and the main power that we have now Is it that the interference here is more than the other one? So can you explain that?
Okay.
Why is the interference more with distributed systems than the localized systems? Can you explain why?
Okay. If I get to what the challenges more with the distributed generation system compared with the grid system?
Yes.
Okay. Well, the focus of this presentation, I didn't really focus much on the grid system, but the grid system is inundated with a lot of challenges too. And that was not analyzed in this topic. I didn't look at that. I'm looking at the benefits that will be presented by the distributed generation and the problems that might come and how to counter them.
No, you cannot talk about benefits because you're trying to get something better than what we have.
Yes.
So you should be able to look at the other one and say, okay, this is the advantages of this one over the other one. So you cannot say you did not look at that aspect.
No, we looked at okay, ma'am.
A comparison between.
Can you figure out my
no answer? I don't need this.
Okay. Now the grid system, one of the major problems with the grid system is that of energy losses. When I started with the presentation, it's a major part, and losses come as a result of a lot of factors. There are several types of losses, but in the technical losses, we have issues with voltage. Voltage is a major problem in our power system. So, which is one of the issues that distributed generation, to a large extent, takes care of. The issue of undervoltage and overvoltage is completely or almost taken care of in distributed generation. And because of that, energy losses are reduced to a large extent. Now, I also mentioned the issue of both voltage collapse and system collapse, which happens regularly in Nigeria. With distributed generation, that to a large extent will be reduced because the whole system doesn't have to come down because of a fault, maybe from a generating station.
Okay, thank you. Thank you very much.
Yes.
So I would like you to lay emphasis more on that aspect and not on the interference part. Thank you very much. Somebody has a question for you online. Okay. So our online participant, please, can you go ahead?
Okay, thank you very much, presenter. I'm very grateful for this opportunity. My question is it worth the while to embark on distributed generation if one has to go through all these problems and mitigating against the distribution generation in order to make it worthwhile? Is it really, cost effectiveness is what I'm looking at. Is it worth the while? Or rather, wouldn't it be okay to focus on the traditional one and really try to focus on areas that are critical so that they are isolated instead of putting everything in one single generation? Something like a network discrimination, such that when there's a problem in a locality, the whole entire area will don't have to be shut down, but rather only the affected area will be shut down. Because from what I see, the distributed generation has a lot of problems, a lot of challenges. Power standard is a problem, voltage frequency standard, harmonics is another thing, and many other things. So putting the cost in mitigating these problems, is it really worth the while embarking on a distributed generation? Thank you very much. Sorry, I can't hear you, please.
Anyway, papers have been studying the initial investment cost for implementing distributed generation actually is very high. but the long-term benefits are worth it. Why? The fact that it takes care of, it eliminates the infrastructure, the cost of investment in transmission infrastructure, which is a major cost in implementing a power system or a grid power system, is taken care of. Then the speed, distributed generation can be quickly implemented and also scaled up. And that is one major advantage it offers over the grid system. It will take, for instance, some days ago, they were in the northern part of the country, there is a line that is being joined, Akwanga 330 kV line. They are upgrading it, and as a result of that, the transmission company of Nigeria had to issue, you know, a statement that this will take weeks to achieve, because they will need to connect a new station to the grid and also increase the transmission capacity. It takes a lot of time. Now, in distributed generation, the time to implement the system is very short, reduced. Though the initial cost might be much, but over time, the long-term advantages, the long-term costs are far lower than that of implementing grid systems. Maintenance also is easier in distributed generation compared to transmission or the grid system as we know. So it is worthwhile, especially in Nigeria, where we cannot wait anymore. Because to implement a grid system right now, to expand a grid system takes a lot of years. To just string let's say a 20-kilometer transmission line will take years. But a distributed generation, in a few months, everything can start ticking and supply is those who need it. Thank you very much.
Thank you very much. Well answered.
So any more questions for him, please? Online in the house? Okay, no more questions. So thank you very much. Okay. So our next presenter is online, and it's Engineer Shomefu, and the title is On the Assessment of Transient Stability in a Structurally Weak Network, Considering the Integration of Multi-UPFC Controllers, a Review. So Engineer Shomefu, can you go ahead, please?
Thank you very much.
Engineer Shomefu, are you with us?
Yes, I'm with you. I'm trying to share my screen. Hello? Yeah, I'm trying to share my screen. Okay. I'm on. Can you hear me? Hello? Hello?
Yes, you're audible. You're audible.
All right. Thank you very much. Good afternoon, everybody. I am going to present the topic on the assessment of transient stability in a structurally weak network, considering the integration of multi-UPFC controllers, a review. My name is Alaba Shomefu. I am sorry for, first of all, let me apologize for not being able to meet up as being the first speaker of the day. I apologize, and I hope my apology is sincerely accepted. Thank you very much. So, going on with the presentation, let me set up the slide so I can start from the beginning. Okay. Sorry, I'm sorry, please. All right. So the outline is as stated. I start with the introduction, a review of reinforcement of weak topological power networks, the integration of fact devices into power system, transient stability and identification of suitable locations for fact device location, and then I conclude the paper. On the introduction, with the ever increasing demand of electricity power from the people, utilities, it has become such a task to keep up with the high level of demand as compared to the supply and the available energy, which is actually almost impossible to go around. So as a result of this, practically or conventionally, it is known to be the conventional ways of using or improving the stability. But before the stability, the increase in load demand tends to affect the stability of the system on its own, because the demand getting more than the supply and what is available, it affects the stability of the power system in the case of any outage, disturbance, and what have you. So in order to tackle this, the conventional ways are to introduce new generators and then add more transmission lines to the existing network. Okay, in doing this, it becomes almost impossible. It is possible, but then when we consider the cost and the volume of space and the time, it could be so time-tasking and time-taking. So as a result of this, the fact device and the fact controllers were designed and developed, and they were integrated into this network system so as to help smoothing the curves, because the stability, once the stability of the power system is affected, it could oscillate. So in order to make the oscillation smoothing and at the end of the day, make it return to a stable position of working, the fact devices are integrated. And so the study of the stability of power system becomes easier with the facts controllers, and it becomes a necessity for utility engineers in order to understand the working principle and the working ways of the network. So the first topic is a review of reinforcement of weak topological power networks. In order to handle the ever-increasing demand, there is a way by which the network can be redesigned such that it will be able to accommodate the demands and it will be able to withstand more load. The process of this is by, the traditional means is by introducing the new lines, and then the impedances are considered. The process of adding new lines to an existing network is what is known as transmission expansion planning. And in order to do this, to study and to understand the transient stability of the network, a lot of theories, a lot of researches had gone into it. And the most traditional of it is the formulation of multi-objective optimization problems. In doing this, the multi-objective optimization problems went a long way, but then there was a problem of having a lot of variables, a lot of things to consider in order to be able to assess the network stability. So subsequently, then came the method of stochastic programming, as used by Alvarez in a study which he carried out in 2007. This brought the uncertainties to a lower level, but then it still was not able to give a good account of the state of the network, because the scenarios to be considered are still so many. And then as a result of this, it becomes a heavy load for the utility engineers to assess and to process the stability of the network. So Bert Simmers and Sim developed a new method called the robust optimization. This is iterative dependent, and it makes it easier because the scenarios to be considered, the variables and the unknowns to be considered became a lot reduced as compared to the stochastic programming. But still, there was still the problem of settling with a lot of variables. And so Alayode in 2018 developed a new method called the structural network theory. Now, this is non-iterative dependent, and it's easier. It's just a way of using the lines and then considering the impedances between the nodes in the network. And as a result of this, it was mathematically easy to execute and to ascertain the transient stability of a network. So integration of fact devices into power system. This is another way. This is another subtopic of the paper itself. Now, in integrating the fact devices, a lot of research as well had gone into it, the direct feedback linearization, which could be seen as a conventional or the traditional way. But the problem or the challenge of this DFL, that is the direct feedback linearization, is the fact that it is not applicable. It is ineffective in all fault conditions. It has its own restrictions to some conditions it can work on and not applicable on others. So in order to take this away, an advanced nonlinear technique was introduced by Yu et al. In 1993. And this is approximation based. But still, it has its limitations, despite the fact that it reduced the limitations of the DFL, it still has the limitation of not being able to be applicable or not being able to be applied to large size practical networks. And how do we go about this? Then came the invention and the research over a new method called the particle swarm optimization, PSO. This is formulated as an optimization solution. Now, the benefit of this is that even when there are very complex nonlinear problems or other things which the previous ones had, this PSO was able to resolve the complex ones, the situations of the network. But still, after all this had gone down, it reduced the effect of the DFL and the nonlinear technique as proposed or as researched by Yu et al. In 1993. But then it was still only suitable for small scale power systems. And then there are other ones that were developed and were researched into. And then came the intentions or the decisions to know which of the fact devices would be best to use. Now we have the STATCOM, which is a static synchronous compensator. We have the SSSC, static synchronous series compensator. The STATCOM is usually applied at the nodes. The SSSC is usually applied along the lines. Now then came the unified power factor controller, the UPFC, which as compared to the two previous ones, STATCOM and SSSC, combines the effect of the two, combines the advantages of the STATCOM and the SSSC. And then as a result of that, when integrated into a network, the result is always far better at determining or at retaining the stability of the network. So as a result of this, many researchers had gone over here to determine which would be best. So in 2012, Amara and Hsan carried out a research. They considered the STATCOM, the SSSC, and the UPFC. And their results showed clearly that the UPFC performed best amongst the three. Now, the transient stability and identification of suitable location for fact device placement. In order to determine the robustness of the power system to now stable and how much of integrity it has, it is determined by the critical clearing time of the system. That is the shortest time by which the system can regain its stability after it has experienced a disturbance, which will be fault, loss of line, and others. So in carrying out this, in identifying the voltage stability index, the VSI, was researched over and it was used. But then the low voltage stability index is voltage based. It works more on the voltage of the nodes in the network. And following that, another one was attempted or was researched, sorry, and that is the location marginal prices.
Okay. I think we have 3 minutes. 3 minutes.
All right. I'll round up now. Thank you. The LMP is used mostly on very long lines. And in this, they consider the cost of integrating these FACT devices and where it will be best as regards the cost, not the other parameters of the line itself. And then the genetic algorithm was also developed, which worked far better than the others, the VSI and the LMP. The genetic algorithm worked better, and it's helped further in determining the right location or the placement of the FACT devices. Subsequent to this, the particle swarm optimization was also developed, which reduced the iteration, which reduced the complexity of the genetic algorithm, and it was way faster in working with the network. Still, a lot needs to be done as regards the PSO. Then came the improved particle swarm optimization as researched by Ravi and Rajam in 2013, which also reduced it further from the PSO. And then again, the brainstorm optimization algorithm, BSOA, by Jodehi in 2015, further reduced the complexity of working with the transient stability of a network. So conclusively, a review method on the improvement of the transient of power system has been presented, and the improvements with time has also been presented. Thank you very much.
Thank you very much.
Yeah.
So please, do you have questions for me? Questions, please. Okay, can you hear me?
Yes, I can hear you.
Okay. So I've looked at your title. It's a very important word there or statement. Structural.
Okay, ma'am. Yes. Hello.
Please, what do you mean by structurally?
Hello. Can you hear me?
I think she is inadvertently muted.
She's doing what?
She has been muted. I can't hear also.
All right. So I'll just hold on for her. Thank you.
Please, can you explain? Please, can you explain the meaning of structurally weak network?
Oh, okay. Thank you very much.
I think that's the starting point.
Yes. I can. Can you hear me now? Hello?
Yes, very loud and clear.
Now, can I go ahead?
Yeah, you can go ahead. You can hear you.
All right. Yeah, a structurally weak network is a network that cannot be loaded up to its full capacity as a result of the load and the demand which is being imparted on it. That was easily defined by Alayonde in 2018 in his paper, and it's also in the reference I made.
Fine, you are not telling us. Please, can you explain further? I didn't hear what you meant.
Oh, okay.
Because that's a key. That's key in your work.
Yes. I agree. Yeah, topology, it cannot be loaded up to the full capacity without yielding. That's a structurally weak network. A network that cannot withstand the load to its full capacity. It could be as a result of distance between nodes. It could be as a result of various things. It could be the lines. That is why the most times it is usually a practice to add more lines into the network to reinforce it, to strengthen it the more. But a structurally weak network basically is a kind of network that cannot be loaded up to its full capacity without yielding. It cannot withstand it fully. That's what it is, man. Hello?
On what it means to on what it means for a power systems engineer. That is just a kind of a general explanation, but there are factors that you can use to determine what a weak network is. For example, the short circuit ratio and the impedance of the network. Those are the things you use. You can't say a network that cannot be loaded. Those are just the result of the network being weak.
Yes.
But you need to determine those factors that can say, okay, this network is weak. So please, I would like you to work on that aspect because it's on your title.
Yeah, can I say some more, ma? Hello?
Now I say, okay, please find out if this network is strong or weak. You can't use that explanation to determine that.
Yeah, can I say something more, ma? Hello? Hello?
Please go ahead.
Go ahead.
Go ahead.
Okay, it's about the power transfer capability of the network, actually. So talking about the power transfer, definitely we are talking about the impedances. While in the process of adding more lines, we are strengthening the line, we are strengthening the network by adding more impedances, by working on the transfer capability of the power transfer capability of the network. So it's not just about it not being able to be loaded to the full capacity, but the power transfer is also affected. It is run in such a way that the maximum power required of the network is not eventually what is supplied as a result of the low demand by the consumers and the other things like the network, the lines, and the connectivity within the network. Thank you.
Okay, you've talked about power transfer, but please, I would like you to, there's a reason you cannot get maximum power transfer. So that's what I'm getting at. You cannot get maximum transfer for certain reasons. So please, I would like you to explore that, because that should be the foundation of your work. It's not just that you cannot load it to limits. You cannot, those are just the result of having a weak network. So please, I would like you to explore that aspect. And then I would also like you to talk about
distance is also part of
bit of transient stability. Thank you very much.
What?
On it. Because she has still reviewed, and I don't know how many papers have you reviewed?
That's like the first paper I'm reviewing.
Ten for a review work.
Yes, the 10 is just for the purpose of this presentation. I reviewed the 9
just
papers.
Take note. Just take note and work on it.
Okay. Okay, ma. Thank you, ma.
I think that's all we have. Okay, so you are here, okay. So the next presenter is Engineer C.U.
Okay, I'm done.
And he's going to present on effective demand response optimization in smart grid, considering battery storage network. So your time starts now.
Good day, everyone. My name is Tutor Chiku. I'm here to present the paper by the following authors and myself. The paper is effective demand response optimization in smart grid considering battery storage network. Now, this the outlines of the presentation. I'm going to the introduction, problem identification, aim of the research, objective, setup, scope of study, literature review, methodology, results, and then the conclusion. Now, the introduction. So, the global energy demand is increasing rapidly, and it's important to optimize the energy needed in order to ensure customer satisfaction. And also, the battery in this case is very good to consider while trying to achieve this. Now, the goals of the smart grid include preservation and safety of the grid, ensuring best use of current power generation, creating a design that promotes more demand response participation, develop a model that guarantees integration of major renewable energy resources. Now, these are the load management schemes that can be used. So we have value filling, load shifting, and peak shaving. Now, problem identification. The first identified problem is supply imbalance. That is the demand response imbalance, then power shortage. The aim of this research is to develop methods that mitigate the level of instability in the electrical grid. And the objective, mathematical formulation of the effective sizing of the battery system, reducing the cost of electricity usage, and minimizing the number of batteries in the smart grid. And the scope of the work is limited to the ideal sizing of the battery that meets load demand requirements. And then the research is focused on the 24 hours time frame for optimization of the battery. And the literature review, Antonopoulos et al. Proposed the use of artificial intelligence in optimizing the demand response. However, the challenge faced with this method was that artificial intelligence approach it was okay, but was costly and it needed a number of data. And these are the mathematical model for both the battery model and the PV cell. Okay, the methods used. Number one method that was used in optimizing the battery was the Firefly algorithm, and the other method was the mixed integer nonlinear programming problem that was applied to the PV and battery system. So this graph depicts is displaying the PV cell and the load. As you can see, the load at the time, especially in the afternoon period, is more than the power generated by the PV cell. So this is the battery for the graph of the battery within that time. And as you can see from 6 a.m. towards the evening, the battery maintains a good depth of discharge. Okay, we also tested with different sizes of batteries to see how the algorithm would function. And in conclusion, the study observed a 30% decrease in operational cost as the battery, the right size of battery was chosen to size the demand response. And the presentation will be useful to power system operations and planners in ensuring smart grid and stability, reliability, and minimizing electricity in peak time, in peak periods. Okay, in future, could be the optimal sizing, the optimal location of the PV cell could be considered, and also a way to operate the entire setup in a safer environment could also be considered. Thank you very much.
Engineer Fisher, thank you very much for that presentation.
Thank you.
Please do have questions for him. Questions online. Questions those physically present. Please, can you go to your second slide? Okay, let me see. So we're talking about battery storage network. What do you mean by that?
That's just the device used in storing power generated from maybe the PV cell, but it has its own energy. So it's just the device like battery. Yeah.
No, you are specific here. So you don't be specific. You are specific. There are other devices that can store energy, but you are specific. Battery.
Yes, battery.
So when you are saying battery network, what do you mean by battery storage network? Okay. I want to understand that aspect.
So I'm just referring to smart grids that make use of batteries as part of their setup.
Then you may need to go and work on this side because it's as if you have a network of batteries somewhere, then connected to your smart grid. That's how it sounds to me. I don't know about. That's how it sounds to me. So I'm interested in knowing how much work you did on the battery storage aspect.
Okay.
Because it's a very important aspect of the work. So how much work did you do on the battery storage aspect of your work?
So this was tested, hasn't been tested in a light site like fully. It was more of simulation and with little battery. So that was how far I went to the work.
So what kind of batteries are we talking about here?
I'm talking about lithium batteries. So lithium ion.
Lithium ion
batteries, because they are more durable and they withstand.
What's the energy level? What energy level are we talking about here?
For the battery. For the battery. Yes. So it depends on the demand response at the
No,
time.
you've done some work on it, so you can give me a range.
Okay.
It may not be specific, but all the range, what are we expecting? Because this battery is supposed to supply,
Yes,
like a main.
but not so it's not on its own. It also depends on the renewable energy. And also, as the future work, I also want to recommend the use of maybe diesel generator.
No, don't go there. Just stay on your own work for now.
Okay, so
you don't know the capacity of the battery.
So capacity of the battery can make it of.
Not you can. This is your work, so don't say can. What did you find out in the course of the work?
So 100 kilowatt battery.
100
kilowatt hour battery. That was what I tested it.
You tested. Okay, can you show me a slide?
It wasn't just that. I tested multiple.
I was about to stop when you said you tested it. So let me see if there's any result.
This 100 kilowatt hour battery.
So you got the battery physically. Did you get the battery?
Yes, I was trying to do the schematic I got was mostly for instruction from the software maybe the.
Okay, thank you very much. Any more questions online? Okay.
How were you able to use the Firefly algorithm to achieve effective demand response? You know, you didn't really address that in your presentation.
Okay. Before now, I wasn't familiar with the Firefly algorithm, but I knew it would be good for a continuous problem such as battery. So I and my friend who was better in it worked with it. Well, I didn't really grasp how it worked, but I knew it was good for a continuous problem such as the battery. Yeah, I'm here to apply.
Thank you very much for the presentation.
Thank you.
Okay, so the next presenter, so the next presenter is Dr. Omeje. So you have 10 minutes, please. 10 minutes. Okay.
Good afternoon, everyone. We are here to present this paper titled Design and Modeling of an Automatic Controller for a Microgrid. Under introduction, a microgrid can be said to be an interconnected node and distributed energy resource within clearly defined electrical boundaries that acts as a single controllable entity with respect to the grid. There has been research on grid systems, especially on the control of microgrids. However, there are some outstanding issues that need to be addressed. One of the schemes that is prevalent in literature is group control scheme. However, the issue bordering on maximum power output or renewable energy resources is usually neglected in the group control, and how to minimize transit and switching time in power sharing is still unsolved. So the methodology adopted is to enhance the typical group control scheme for distributed generators. The figure shown in that figure 1 is the block diagram of a typical distributed generator. Okay, so the control is shown in figure 2. You can see the control of the distributed generator shown in figure 1 is done by measuring the output, voltage, and current from the filter. Now compute the instantaneous average active and reactive power output. Then compute voltage and frequency via two equations. Then generate voltage reference for inverter. Then finally, the generated, will now generate pulse width modulation figure to the inverter used to control the inverter system. The group equations are shown in figure 1 and 2. The group characteristics is shown in figure 3. Then figure 4 shows how the maximum power can be tracked. How you can track the maximum power in distributed generators. Now, results and discussion. We use the system shown in figure 5, where you have 2 DGs, and then the utility. Then there are 3 loads here. The local load, variable load, and the load that is very close to the utility. Okay, test scenarios. We studied 4 test scenarios. The first scenario is when one of the DGs is on and then the grid is off. The second scenario is when one of the DGs is on, then the grid is on. The third scenario is when 2 DGs are on, now the grid is off. And then lastly, when 2 of the DGs are on and the grid is on. The parameters used for the simulation are presented in table 1. Now, this is the load profile. Figure 3 shows the load profile we use. You can see that the load is not steady. We use a variable load to see how the group controller can solve the identified problem. We have the active You have active, you have the active power, and then the apparent power. Then figure 7 show the output power for DG in scenario 1. If you look at the active power and the reactive power and compare it with the low profile given earlier, you can see that the output power of the DG, was able to coincide, or rather, was able to supply the exact load for the load. You know, there are 3 loads here. They have almost the same waveform. Okay. Figure A shows the voltage and frequency of the oscillating microgrid in scenario 1. As you can see, the voltage and frequency they vary. When the load in the microgrid is high, the frequency tends to be reduced from the normal value 50 Hz, because you 50 Hz rotate the frequency. And when the load drops, the frequency goes up and all that. And also the voltage, there was also a slight deviation in the voltage level. Then figure 9 shows the power output from the DG and the grid in scenario 2. That is when you have one DG operating and then the utility. You can see that the power output from the DG, that is the one up here, is relatively stable at the beginning. It's operating, that's why the DG is operating at the rated output. But meanwhile, the power output from the generator is secondary. In other words, priority is given to the distributed generator. Okay, that's the frequency. You can see that the frequency doesn't vary much because it's connected to utility. But how can we improve it? Suppose that the microgrid is working in isolation, how can the frequency and the voltage be stable? Now, the next scenario, the scenario 3 and 4 shows when 2 of the DGs are operating and the utility is on and off. Figure 11 shows when the switches are on, but the utility is off. You can see that the power output from the DG, the active power from the DG1 and DG2, they were able to follow the low profile given earlier, and they were able to share the load based on the ratings of the DG. That is the frequency. You can see there's also a slight variation in the frequency, although the frequency variation is not as high as in the first case, because the system is now more robust. There are 2 DGs operating, and it makes the system to be more robust. So the load doesn't affect the DG much as in the first case. Then figure 13 is the power output from DGs from the microgrid when the 2 DGs are on and the grid is on. And here the 2 DGs are operating at rated output, while the grid is okay. Why the grid is just like a backup. It's when if the load increases beyond the rating of the 2 DG, that's when the grid can come on And then the excess of the power can now be given to the grid. That's why you have some negative value in the power output of the grid. So this is how the power, we're able to track the maximum power from a renewable energy. You know, as some like a solar energy is not steady. In the day, that is in June, you have the maximum output from solar, but you know, when night comes or towards evening, the output will decrease. So we're able to track the maximum power and injected it into the developed group control scheme, and we are able to obtain results that are satisfactory as in the first case. So you can see the output of the current and voltage. They are not though they are little distortion, but the distortion is not much. That shows harmonic is highly reduced in the system. So in conclusion, the world has been able to demonstrate that the typical group control being used everywhere or being used in the past can be modified to solve the identified problem, and that's what we did here. And the priority is given to distributed generators in this case, and we're also able to, you know, track maximum power from the renewable energy. So if this kind of system can be deployed in real life, I think it will go a long way to solve some existing problems. Thank you.
Thank you very much, Dr. Major. Please we'll invite people to ask questions. Please, if you should ask questions, please. We don't want to be the only ones asking questions. Questions, please. Dr. Ibazi, any questions? Okay. We were talking about, can you go to the slide when we were talking about gaps? Gaps in literature. Because I'm trying to understand how you feel whether you, I think the first 3 or 4 slides. Okay, you said gaps in literature. So how did you feel those gaps?
Okay, thank you for your question.
Resources is usually neglected in group control schemes. Then how to minimize transient and switching time in power sharing is still unresolved. So did you try to fill those gaps? Or you just mentioned them?
Please, moderator, can you go to, because I think, go to the next slide. Next slide. Next one. Next one. Yeah, here. So this is one of the this is a flowchart of one of the things we did to fill one of the gaps. Here we try to track the maximum power output from the DG. You can see the first block there says take approximate the measurement of input power. Then we have a safety factor 0.9, which we use to multiply the approximate input power. Then there is a diffusion block here. The power output, when you multiply those two things, you now get the assumed rated power is it greater or equal to the reference power? If it is yes, then increment the reference power. That shows that the power available is higher than what is meant to, or the constant value that normally gives to the controller. So we're able to track the power input, from renewable energy to make sure that once the power increases, then we use the increased power value instead of a constant power value that's being used in previous work. So with this kind of thing we developed in the software, we're able to track maximum power and injected it in the control for the general control of the microgrid.
Now the DGs you are talking about, are you trying to use it to replace the utility system, or you want them to work with it? I think most of villages in Nigeria still don't have electricity supply. Have you ever considered the DGs in those areas, or you are still concentrating on those areas that already have electricity?
Okay, thank you for your question. The system we designed can be deployed in any of those two scenarios. In the remote areas, they don't have access to the grid. In that case,
sorry to interrupt you, because what you have there is only a comparison. We are only integrating it into where we have electricity already. Okay. So you are making comparison. So in a fresh place where there is nothing to compare with, what are the problems you envisage if you are just going to put your DGs in such areas, so deploy your DGs in those areas? What problems do you envisage? Because now you have a yard, but in those areas you may not have a yard. So what problems do you envisage?
Well, I don't think whether I understood your question clearly, but I know that anytime you want to deploy new technology in an area that has an existing network, like a grid network, for example, a number of things come to mind. You have to consider the load usage in that area. How do they use, how do they put on the appliances, and all that. So you put all those into consideration in your design. And of course, there are some fundamental problem or inherent problem in power system that need to be, considered. But that's what I'm saying. I don't really understand the area you're going. You.
Yes, maybe I should throw more light. Now, Madam is asking for areas where you do not have connection to the grid, the problems that may be envisaged. Now, one of the problems is, when you have the grid network and the parameters of the grid you need to synchronize into them. But now, when you are creating a mini grid or microgrid where the grids do not exist, now this particular method of control, which is the true controller, is able to really form the grid in such locations. Because if you are deployed inverter-based resources, you need to be able to specify the voltage magnitude, the frequency, the phase sequence, and the phase angle. Now, these four quantities are what we synchronize to the grid. Now, group control is a method which is used for inverter forming grids. So this kind of inverter will actually form grids in those areas. And if at all we're having other inverter-based resources as well, we have to synchronize to the grid which has been formed by this one. So the issue of having this dwindling frequency, deviation, and what have you will be effectively taken care by the group control. It's very good to form the grid, and that's why in literature you find them using it for grid forming inverters. The other type of inverter, which are grid follower, they use PLL, the phase lock loop. That means the grid must have been formed and will have to be synchronized to those parameters. Thank you.
Thank you very much, Dr. Susan, for that presentation. I think, okay, so maybe I should hand over to the HRIP. Where is the coordinator? So that's the end of the presentation.
Where are you? Has been a long and fruitful day. I think what we are going to have now is this really coming to present statistics to those who are presenting their work to us as part of this conference. HOD, the host. Well, since I have the microphone, let me just use the opportunity to appreciate every one of us that are here, everyone that has contributed. It has been a fruitful 2 days of activities. We are able to go through these 2 days because some people took out of their time to devote to this. I want to appreciate the honors work that the organizing committee of this conference did. Members of the committee are Dr. Adeola Balogun, Adewale, Friday Ogoy, Akitunde Alayade, and Alexander Okandi. They really put in everything to ensure that we had this conference. It is like it did not take place. We recall that the first time the conference was scheduled to take place in July. Unknowingly then it fell on Saturday. It had to be postponed. It was pushed after the exam. Then the new wave of COVID came and the session was extended. It fell within the exam. It was muted that should we postpone this conference again? They said, no, let's go ahead with it. And thank God we didn't have to do that. It only whetted our appetite that next year the committee will go back and come up with a much improved and better conference. And I want to appreciate all those who chaired sessions, especially this afternoon session. I want Dr. Florence Olabali for the masterly way to handle the session. And all those who presented this afternoon, thank you for your presentation. In closing, I will call on the head of the department and the host of the conference
Dr. Sunday Additional, to present certificate to those who are here before we go. Dr. Additional. Good day, ladies and gentlemen. Once again, yes, okay. There's need to thank all our participants. There's nothing that is having a beginning that will not come to an end. Even we human beings, we are born, and there is a time we go, whether we like it or not. Whether we live 1 million years before we even go, but we are going to go. But thank God we started this ceremony, and this hour, the ceremony is going to bed. We thank God for that. And once more, I still need to thank our supporters, those people that sponsor us, those people that support us. I remember my boss, my supervisor, Professor F.N. Okafor, FBNG, they supported us. Here you are, thank you for doing that. And I remember my good friend, Mr. Laide Omotola, came yesterday. He did wonderfully well. Laide, thank you very much. I remember a friend of mine too, Dr. Bolaji Onosoya, the Dean of Engineering, Yabatet. Where you are today, we thank you for doing wonderfully well. And we remember our special guest of honor. Despite the fact that the time we informed him of our conference, he sent our representative. We thank you very much. And they are for me to thank our LOC, members of LOC. They did wonderfully well because they are the one that planned this particular conference. Me, I just initiated it. As an administrator, my own is just to see. Then they carry on the battle, and they did excellently well. Then, by special grace of God, may God spare our life. July next year, we are still going to invite you. And our LOC, they are still going to remain doing the wonderful things they have done. They are still going to repeat what they have done today. And when I was trying to give my welcome address yesterday, this particular conference is going to be a unique one. Why? Why is it going to be unique? There are many reasons why it's going to be unique. Because I've told you, first of the best papers will be taken or will be presented to DER committee, the Journal of Engineering Research, and those papers, they are going to appear there by special grace of God. So we are presenting that here. And apart from that, that is the co-chair, including the chair of this particular committee. They told me that they have tried for the best presentation. I think that is another thing entirely because we have not done that one before, but we are going to do that. But I don't know how Dr. Adiwali and Dr. Pablo is going to do that. Maybe that one is going to be done now, or I don't know, because we have not met and discussed that. That one is just coming in now. Yes, I forgot to mention one big beautiful organization, MTN. They gave us internet FOC. Thank you for doing that. And the next time we are still going to be inviting you to come and do what you know how to do best. Thank you. So that is most of our papers we appear in this house, and authors we are going to tell you what to do because we have gone through that, but we have just done the presentation because we are going to use the JR template, and you are going to carry out what our reviewers, what they have suggested for you to do. Please do that so that there may be a special edition for this. That means if you can have enough paper to meet up with a special edition. But if you cannot be able to achieve that, part of the papers will be part of the next edition of the JL. I'm going to push it forward.
because I'm a member of JHL. So that is, there's a way of doing that. We are going to play politics and we are going to do all those things. So to be able to get there. I will say that. You say, then I will now present the certificate and I will now wish everybody let's journey to your different destinations. And one thing again is this, that is, if there's error in your certificate, just tell us. We are going to do necessary corrections. And those people that are not here, we are going to post, or we are going to send the certificate to them 2 days or what have you. All the ones that we can avoid. So that is that. So let's just be doing that. And think Dr. Flourish, Olobaniyi will come and assist. That is a woman is going to do better. So yeah, let me just okay, let me be calling the names and we'll be keeping up. Okay, I don't like to be okay. Engineer, no, let me use my second eye. Engineer Ogunlowo Temitope Francis. Are you here? Engineer Ogunlowo Temitope Francis, the certificate is here. If you please, I don't know, we appreciate it. If you can just send us your mail address, yeah. No, it doesn't matter. We just have to honor them. We are going to play politics. We need your address to forward it to you. Mr. Ajayi Michael Babatunde, are you here? Wow, come forward and come and receive our ex-3G coordinator and chief. I will do the two of us to do that. So then, thank you. Okay. I'm a local man. Okay. Mr. Onolapo Abiodun Joshua. Is the man here? No. It's online. Please, we need your address. Mr. Ogundipe David Olapode, online. Engineer Namdi Chukwueze Wilson. Engineer Wilson Namdi, we need your address. Mr. Lawal Teslin Alao, if you are there listening to us, we need your address. I'm going to post it to you. Engineer Ajayi Vincent Ayodeji. Engineer Ajayi Vincent Ayodeji. Is he here? Is the candidate here? No. No, this one is the UK. Dr. Bature Amir Abdullah. So Abdullah, please just, okay, we are going to forward it to PUK, Department of Electrical Engineering. So Engineer Niyi Narajana Jacqueline, I think Dr. Diwali is going to take that one. Jacqueline, no, okay, we are going to forward it to where the man is. Engineer Adepoju Olugbinga Ademola. Engineer Adepoju Olugbinga Ademola. We are going to do that. Engineer Adidayo Otimi Muiwa. Engineer Adidayo Otimi Muiwa. This online of it in our Engineer Oyetola Jamiu Babatunde. Engineer but it's a friend of mine. We are going to forward it to Lagos people today. Mr. Igwe Chinua C. Mr. Igwe Chinua C. Engineer Oyetayo Abiodun Ebenita. Engineer Oyetayo Abiodun Ebenita. Mr. Shumefun Alaba Ujibamidele. So, how are you? Thank you very much. Thank you. Yeah. Yeah. Okay. So yeah, again. Thank you. No, these are on Dr. Adebisi John. On here. So having done that, once again, we thank you for honoring our institution. We thank you for playing an active role, for playing active roles in this particular 3IConSET. And I wish every one of us next journey to a different destination at Izebari, Ayinokuri,
whatever. Then you can now go for our lunch. Thank you. This is supposed to do this, but I'm doing it. I now declare the conference closed. Dr. Elsu Aditono, Head, Department of Electrical Engineering. Thank you.
Yes.